My name is Sean Ruffle, and I'm a Linux kernel developer for Digium, and I primarily just maintain the DAHDI drivers. I don't do a lot of asterisk development, per se. Um, but I was planning on just kind of rapidly going through this because a lot of people, DAHDI is kind of like the compiler. Like, you just want it to work, and if it doesn't work, that's only when you care. That's not where most people are doing their value add. So I'm going to go through this quickly and leave a lot of room for questions at the end for people who have specific questions about this. So basically in my talk here, when we're done, I want everyone to know what DAHDI does and when you need it, how to basically install and configure it, the general architecture of DAHDI and how audio moves through the DAHDI layers up to asterisk. I'll look at some of the utilities and tools that might be useful for debugging your installations, and then some future directions, and then again leave a lot of room for questions at the end. So DAHDI is a collection of kernel modules and associated utilities that, one, provide device drivers for telephony hardware. So if you have your analog cards, your TDM400s, or your digital cards, DAHDI provides the device drivers for that. DAHDI also provides conferencing and bridging and DAXing or crossing between the channels, both on single cards and between channels on different cards. So when DAHDI was originally proposed way back when by Dude, that's how I know him, Dude. It was basically kind of proposed to be a pseudo TDM bus to make the software layer act as simulate a TDM bus that would be in hardware, and that's why it can cross and bridge channels between different cards. It also provides timers for asterisks that are synchronized to clocks recovered from telephony hardware. So this is really important. So if you have a PRI line, which is a digital link to your telephony provider, you want asterisks to use the clock that you're getting and recovering from your PRI line for all its mixing and timers, and DAHDI does that. DAHDI also provides software echo cancellation for channels, and it does that through a series of modular echo cancelers that you load and attach to channels. It also does tone generation for DAHDI channels, so it'll generate the DTMF and it'll generate the dial tone and stutter tone, and that's done in the kernel. It also provides gain control. And again, that's done in the kernel because some hardware has the ability to do gain control on the hardware. So by having DAHDI provide gain control services, it can do it in software if the hardware can't provide it, but otherwise it'll just do it in hardware and save some time. And it provides HDLC framing in software on raw channels. So this allowed a lot of the early hardware that DAHDI provided to be simpler and less expensive because more of the work was done in software. And that's also the reason why DAHDI supports software echo cancellation from the very beginning. And tone generation, I have that twice. So you need DAHDI if you want to directly connect your asterisks on a single server to the telephony network. You also need DAHDI if you were on an older kernel prior to 2.6.25, where timer FD was added to the kernel. And if you're on a version of asterisk prior to 1.8, because that's when asterisk started supporting the timer FD. You'll also need DAHDI if you are on a version of asterisk prior to 1.8 and you want to do conferencing. Because MeetMe requires DAHDI. MeetMe does all the conferencing in the kernel, uses the kernel facilities. And that was originally put in because DAHDI already had the facilities to conference channels to support crossing, and asterisk could just go ahead and use the mixing that was already there. And the page application also uses MeetMe to do its mixing. And just as a side, DAHDI was also previously known as Zaptel, so a lot of the old information you'll see out there refer to Zaptel. Basically, that's DAHDI now. Digium had to change the name due to a trademark conflict with a company that owned the Zaptel trademark. So installing and configuring, basically, just like asterisk, you just want to make sure you have the kernel headers. That's the biggest requirement that most people have problems with, because DAHDI will want to build for the current version of the kernel that you're running against. Then there's some SVN commands there. That's it's in the README if you want to look at them. And again, packages. Digium provides packages for CentOS 5, and other distributions maintain packages. And I know Zafir Cohen at Zorcom, he maintains some of the Debian packages. And there's some work there to coming up to make it a little more feature complete to add the firmware packages in there. DAHDI versions. DAHDI uses a 4-point versioning system, and this is a little different from asterisk. DAHDI is kind of more run like the kernel. It uses a kernel development process more so than the asterisk development process. But the goal here is that for any A and B number, somebody should be able to move between any C and D number without causing any regressions with their configuration. So you can be assured that if asterisk works with 2.5, asterisk will also work with 2.5.1, 2.5.2, and that's the primary consideration for determining what goes in a branch of DAHDI. maintaining that compatibility. And tools and DAHDI Linux don't necessarily require the same versions. They happen to be that way, but it's not a requirement. And also, as a personal request to me, if you're doing any kind of development, if you run from DAHDI trunk, I encourage everyone to do that, because the rate of change in DAHDI is a lot slower, because problems in DAHDI have larger consequences than problems in Asterisk, because you have data loss, and so the pace of development is a lot slower. And if you run trunk, normally when somebody has a problem, it'll be closed within a week if it's a known bug, because we jump on it right away. You can get your name in the commit message if you find something and report something. So I really encourage everyone to run trunk, and I try to make it beneficial for people to do that, mutually beneficial. So now the configuring part of the install and configure. If anyone doesn't know about DAHDI GenConf, that's the recommended way. If you put a physical telephony card in your server, if you run DAHDI GenConf, it'll generate a good set of default configurations that'll handle 99% of the cases that people have. The different configuration files that can be generated are the init script, and that actually, when your server starts, that actually loads and processes all the other configuration scripts. There's a system.conf that describes the parameters that you need for the individual channels and spans. There's a DAHDI modules that defines what actual board drivers are going to be loaded in the kernel when the system starts. And that's necessary because DAHDI has to actually blacklist all the kernel modules, because the order that the cards register with the core of DAHDI determines the span numbering. So only by blacklisting and then having the init script load them serially can we guarantee the span numbering when people have different kinds of cards in their system. There's the DAHDI.conf and the mod probe, and that's where you can add module parameters that will be loaded every time you start DAHDI and start your system. There's a blacklist, again, that UDEV uses when the system boots to block automatically loading the drivers. And then if you also are using FXOTune, there's an FXOTune comp file that describes parameters that's going to be set on hybrids of certain FXO cards. And that's important for reducing echo at the source, because a lot of the analog echo happens at the mismatch on the hybrid on the analog cards. So FXOTune, if you're having echo problems and you have an analog card, definitely try to run FXOTune. Also, some honorable mentions that aren't really in DAHDI are the Chan DAHDI configuration files that a lot of times that needs to match with what you have in system.conf. And then there's also a licensing file if you're using HPEC, because that's a kernel module, but you have to have a license and actually to start it. So then you go ahead and when you're configuring, you go ahead and start it. But most of the time when I'm developing, I don't really ever use the start scripts. I just mod probe it directly. So now this is the general overview of the different parts of DAHDI. So at the very bottom, you have your different hardware cards. Above that, in the kernel, the blue blocks are the kernel part of DAHDI, and you have the blocks with the dotted line around the outside. Those are the board drivers. So those are the things that actually have PCI identifiers assigned that UDEV is going to try to load when it sees those devices on the bus. Also, some of the board drivers, like on the DAHDI voice bus on the bottom left, use common libraries that are used amongst different board drivers, so that's what that's representing. And that's actually what's talking to the physical hardware. There's also the transcoder, the TC400. It uses a separate DAHDI transcode that allows transcoding channels to be advertised between different transcoder cards, and that's what it does. And then there's also a collection of modular echo cancelers. So most people, if you're just doing a default install, you're only going to have DAHDI EchoCan MG2 installed, but there's other ones available that you can use. So above that, up in user mode, now in the orange, you have your DAHDI tools that uses the user mode, kernel mode interface, and you also have Chan DAHDI that's running inside the Magic Asterisk block. At MeetMe directly interfaces to DAHDI. Codec DAHDI will directly interface to DAHDI, and then Res Timing DAHDI will directly interface to DAHDI. So I'm talking about essentially everything in the blue. The blocks in the orange are the parts of user space that use the kernel modules. Another way to look at the architecture of DAHDI is to look at the different data structures. So on the left side, we have DAHDI data structures, and on the right side, we have kernel data structures. So at the very bottom, each of the board drivers have their own data structures that define the board and how to talk to the specific physical board, and those kind of have a direct analog to the kernel's bus and more general structures like their list handling structures, their PCI handling structures, their USB handling structures. You go up one level from the board data structures are the channel structures, and each of these define the individual channels that the card provides. Now, each of the channel structures in the kernel is associated with a file. So when you actually open your dev DAHDI 1, dev DAHDI 2, the kernel will create a file structure, and then in the kernel, that'll be actually associated with a specific DAHDI channel. Channels are grouped into spans above that, but there is no interface directly into the kernel to look at the spans. So if you want to see any span information, right now you have to get out of the proc file system or use DAHDI scanner or something like that. But the spans allow DAHDI, the core of DAHDI, to know about the relationships between channels, and it provides some information like the default encoding. And then above that in gray, that's a little preview. That's not actually in any release version of DAHDI now, but it's going to be in the next one, is that spans are actually going to be collected into DAHDI devices, because there are a lot of devices out there that have relationships between spans, like timing. Like if you have a 4-port card, there's going to be a timing relationship between the different 4 ports. The DAHDI device will allow the core of DAHDI to now know the relationships between the different spans. So that's not there yet, but it will be there. And then that has an analog in the sysfs, the struct device in the kernel, so that now the DAHDI devices can be placed in the sysfs device tree, just like all the other devices, and that allows us to do a lot of nice things going forward, such as getting rid of the blacklist, because now you'll know the relationships between the devices and the spans. And so that's going to be in the next release, but it's not currently in any release version. Another way to look at DAHDI is to look at what happens when you actually power on your computer. So you turn on your system, it boots up, the kernel boots, it starts. The UDEV script is normally the initial part of the system startup. It's going to scan the PCI bus, or the buses, the physical buses on the system, and look for any device that it already doesn't have a driver attached to. So it's going to see the board drivers, the TDM410, the TC400, and it's going to want to try to load those right then in parallel. Each board driver is going to be loaded in parallel by the kernel. That's where UDEV goes and looks at the blacklist and says, I'm not going to load the drivers for these cards because we can't handle the race condition when they're loaded in parallel. After that, the system continues to boot up, and eventually the DAHDI init script will start running. And then the init script looks at the modules and starts processing those and loads the cards in those orders. When the cards load, they register themselves either as spans or devices with DAHDI core. And then the process of doing that creates an event in the sysfs file system that UDEV then goes and processes to start creating your dev DAHDI control, pseudo, channel, timer, transcode files in your dev DAHDI, in your device file system. And those are what Asterisk and DAHDI tools actually opens to communicate with the drivers. So when you look at that, the control is just a general file handle to do octals that are channel-wide, like load the tone zones or assign echo cancelers to channels. The pseudo channels, whenever one of those channels is open, just a general channel will be opened up to you for pure software mixing. So if you're using MeetMe, Asterisk will open a pseudo channel, and then pseudo channels can be dropped into conferences and mixed just like as if they were physical channels. The channel is just a way to open up, like if you have more than 256 channels in your system, you can open up dev DAHDI channel and then specify what channel number you're opening. And the timer just provides a general timer service for Asterisk that's replaced now by timer FD. And then if you have a transcoder card, dev DAHDI transcode will be created, and that's what's opened up by codec DAHDI in order to do the conversion. And right now, in DAHDI, only a G729 and G723 transcoding is supported. And then if you have less than 256 channels, you'll get a dev DAHDI 1, 2, 3 for each of the channels they have installed. So then DAHDI config will run after all the board drivers are loaded up, and it'll start processing DAHDI system.conf. And this is the time when the spans have their timing and line preferences set. So whether you want to provide timing to the span, recover your clock from the remote side, whether using HDB or B8ZS. Also the signaling modes for individual channels. So for your analog cards, you'll have FXO, FXS, whether it's a B channel or a D channel or a clear channel. But if you're installing a PRI card, you'll know essentially what those mean. And if anyone has any questions, I'll be more than happy to answer them. Then DAHDI config then loads the software echo cancelers by assigning them to the channels. And then finally, the tone zones are loaded in DAHDI config. So after that, the init script then proceeds on and it runs FXOTune, if there's an FXOTune configuration file, to do any of the hybrid parameter setting. And then finally, the HPEC license is activated. Asterisk starts, and then you do your value add. Some of the utilities and tools, DAHDI config, we talked about that. That's responsible for processing the system.conf. DAHDI tool is a debugging aid and allows you to see when spans are greened up and what the actual configuration of your analog spans are, whether you have FXO, FXS modules on them. It also allows you to look at the raw bit signaling state of the channel, so sometimes I use it for that. DAHDI scan will give you a lot of the same information that DAHDI tool will give you, but it's not an ncurses based application. So if you want to script something, you can use DAHDI scan to script to see if your channels are on alarm or something. I also use it to get my BRI terminal type, which is not available in any other way. FXO tune, process the FXO tune configuration file to set the hybrid parameters. DAHDI test will tell you if your timing is within a reasonable amount, and it does that by opening a pseudo channel and reading from the pseudo channel, and it wants to get 8,000 samples every second, and then it'll tell you how far off your timing is. And one thing about DAHDI test, if you're running that, I recommend running it with the V parameter, because sometimes you'll see like 99.98, 99.98, but it's going above and below because there's jitter on the line. So as long as the overall difference is right around 100%, you're good. So if you run it with the verbose option, you'll get that information. If you're doing pure only using DAHDI for mixing software channels, you'll see more jitter because the internal timer in DAHDI runs at 4 milliseconds, whereas all the telephony cards in there provide their samples at millisecond intervals. So sometimes when you're just running DAHDI tool, you'll see it jitter a little more, and that's nothing to be concerned about. If you look in the verbose, you'll see that it's not really a problem. DAHDI monitor allows you to record the audio off of really real physical channels, and if you're having problems with DTMF or with your analog cards, that's an important first step, just to grab the DAHDI monitor and see what DAHDI is providing to Astras. And DAHDI main is a tool to provide framing counters if you have a digital line. And also, what I primarily use it for is to put your digital lines into loopback, and then you can run pat loop test on them. So a lot of times, if you're having problems, use DAHDI main, put your digital line into loopback, run pat loop test, and if you're getting data drops, then that will isolate help you isolate where the problem is. So some future directions of DAHDI is it's undergoing constant development, but there's not a lot of people who are really doing it. But DAHDI will always need to be constantly co-evolving with the kernel, because the kernel interfaces change, and DAHDI has to change to match. DAHDI also follows the kernel coding conventions as opposed to the asterisk conventions, because it wants to minimize the mental shift of a kernel developer to work on DAHDI. There's always new hardware, and hardware's getting refreshed and end of life, so that's a constant source of churn in DAHDI. There's also the sysfs work that's being done, and in the 2.6 release, a lot of the initial work will go in, but it won't really be advertised for use until 2.7. But again, what this will allow you to do is really speed up the time to boot, because now all the board drivers will be able to load it in parallel with your other drivers at system configuration time, and a lot of the firmware loading can happen while the other early init scripts are running. So the goal of that is really to speed up the time from when you power on your system to when you can start Astras up and start processing calls. So I'm personally excited about that. And then there's always the move to optimize. So moving the echo canceller out of the interpaneler is in the works. Moving conferencing out of the interpaneler. A lot of the mixings happen in an interpaneler right now in DAHDI. Eliminate unnecessary transcoding when conferencing. A lot of times when you're doing conferencing, things get transloaded to ULaw and sign linear back and forth several times. So that can be optimized. Adding timing domains, like I was talking about with the devices, for the domains between the spans. And just, when you're running the interpaneler at 1,000 times a second, microseconds count. You shave a few microseconds off here, you're getting % of your CPU to do the work that you want to do up in Asterisk, as opposed to just processing the interpaneler. So that's the rapid fire DAHDI, but I can go into depth in anything else if anyone's more interested.